I wanted to sync up on is
Okay.
the federated resource quota proposal. So
Mm-hmm.
I addressed some of your feedback on the PR. Um, I think
Mm-hmm.
from the meeting last week, we had a couple things that we wanted to make clearer. So we wanted to add a user story for the motivation, just to make that a bit more clear. Hopefully, the user story that I added paints a better picture of why the feature is needed. Um, Additionally, the controller design needed some optimization. I added a suggestion for potentially using a cache, or we could just filter resource bindings based off of the resource quota that's defined there. Um, that's more of an implementation detail, but I think we can discuss that more when we get to that part of the implementation. And then lastly, I think there had been one comment about potentially separating this out into a different API besides the federated resource quota. But perhaps there was some confusion since there is a decent amount of overlap between the API that I'm suggesting and the existing federated resource quota. So what I wanted to do is kind of get on the same page as to what we should do for the API definition here, because we could keep this as a feature within the existing federated resource quota spec, but it's a bit distinct from the static assignment of resource quotas. So what I'm envisioning for this feature is that the actual resource quota or the resource usage is something that's going to be tracked by the Karmada control plane directly. Um, so does it make sense to have it be its own resource quota enforcer API, or would you rather us use the existing federated resource quota and instead introduce like a default behavior where it would be
Mm-hmm.
gating the resources on a Karmada control plane level rather than scheduling resource quotas to different member clusters?
Okay. Uh, in my opinion, I think we can uh, enhance the existing federated resource quota instead of start another API because the feature you are requesting is exactly the in the scope of the federated resource quota.
Yeah.
So if we want to start another API, we still need to uh, explain the relationship between the federated resource quota and the new one. So I also uh, look at the okay. How about share my screen? I also looked at the new API. I think it's quite similar to resource quota. So I'm not quite sure the if we have enough the reasons why I mean I'm not I can't understand the reason why you are requesting a new API.
Um, so to be clear, this doesn't need to be its own API. I thought it made a little bit more sense just because the existing federated resource quota isn't
Mhm.
so much a resource quota itself, more so just a scheduler of resource quotas, right? So, um, like Karmada doesn't currently enforce any sort of limits directly on the Karmada control plane. Instead, it's essentially delegating a bunch of resource quotas to member clusters. And then
Mhm.
it's up to the member clusters themselves to enforce that quota. Um, so, for example, like if you're using the federated resource quota as is today, you could statically assign a bunch of resource quotas to each member cluster. Once those resource quotas become saturated, you can still apply resources to the Karmada control plane, but those resources won't actually get scheduled because the resource quotas are full, right? So what I'm more interested in is having something that's actually enforcing those limits directly on the Karmada control plane level. And so it prevents users from applying more resources than is available via their limit. Um, so that's what the proposal was. Now, we can include this as part of the existing federated resource quota, but I just was curious if there would be any confusion about the usage because the behavior that I'm trying to do, again, we're enforcing limits directly on the Karmada control plane, whereas static assignment is just scheduling resource quotas. So do we want like a separate resource that's dedicated to scheduling resource quotas and managing resource quota that way? Or
Mhm.
do we want a separate resource to actually manage the resource quota directly on the Karmada control plane level?
Okay. Uh, at the last meeting, I said I will revisit the design of a federated resource quota, and you can see that uh, we planned the different use case of the regarding to manage quotas on Kamada. I think the static assignment just one of the use case, and for your use case, I think we can start to add the dynamic assignments. Uh, in that case, you probably don't need to set this static assignment.
Mhm.
So I think that that means without the static assignments, Kamada controller to will not to set a resource quota to each member cluster. It probably manage the overall quota just on Kamada control plane.
Mhm. Yeah, and I agree with that use case. I guess the confusion for me is just the naming of the feature because
Mhm.
that doesn't really sound like we're dynamically assigning anything. It just sounds like we're controlling it directly in the Karmada control plane. So uh, could we maybe rename that to no longer say dynamic assignment to be something like, I don't know.
Do you mean rename this field name?
Yeah,
Yeah,
just
sure. Sure.
because we're not going to be actually assigning resource quotas to the member clusters in this feature. So I don't
Yeah,
know if
sure.
assignment is the correct term.
Okay, you can maybe we can propose some options. Uh,
Okay.
that's the reason that we didn't introduce dynamic assignments at about 2 years ago because we don't have enough user feedback, so we don't know
Mm.
um, how uh, to do it. So I leave some possible possibility to the on the comments. This one because I just draft idea that maybe we need resource quota can be balanced between uh, member classes, but I don't know the the behavior we. I don't know how we need. I don't know the use case, so
Yeah.
just leave the comment there here.
Yeah, that makes sense.
Mm.
I'm wondering, how would you feel if instead of even defining this dynamic assignment, what happened if we just defined like a default federated resource quota behavior that depends on the overall field? So let's say, for instance, you don't want to statically assign resource quotas, so you just
Mhm.
leave static assignment out of your federated resource quota definition. and you just define the overall limits.
Yeah.
And in that case, Karmada can keep track of what the overall usage is in the Karmada control plane and then prevent users from going above those limits. And that would be just like a default behavior.
Yes. Yes. So I think we can introduce the any fields we need to the API. I don't think this will bring any misconfusion to this API because each field maybe represents uh, maybe represent a different use case.
Okay. So just to confirm, because we can go edit the proposal after the meeting, would you rather we define a separate field within the resource quota that will be specific to our behavior, or would you rather us just use the overall field that already exists?
Uh, Let me see this one. Do you mean introduce another fields?
Um, we wouldn't introduce any new field. It would just be using the existing overall field within the federated resource quota spec.
I,
And
I think it depends. If we need more configuration to declare the behavior, if the current overall field is enough, I think that's fine with that's fine not introduce another fields. But if we need more fields, I think we can add more.
okay.
So do you think we need another field other than the overall field?
Um, the only other thing that I can think of is potentially defining like a resource selector for the resource quota. So that would be kind of analogous to like the priority class that usually is set on like a native Kubernetes resource quota. But perhaps like even if we don't define that, um, overall itself should be sufficient because the user is going to define what the overall CPU and memory limits are, and then
Mm,
Karmada can tally up what those like what the usage of that overall limits is in its
mhm.
status. And then whenever users try to apply a resource that goes above those limits, we can deny the request.
Okay, okay. That means the something like we need to declare the resource scope, and with the scope that means we some of the resource the workloads may be enforced with the resource quota, and some workloads maybe not, right?
Yeah, correct.
Hmm. Yeah. So in your use case, you just have one workload that's the Flink deployment, right?
Hmm.
Okay,
Yes.
I think in that case, how about let's start with a simple version. That means we uh, at least in for example, at least in the Alpha version, uh, we can just have an overall quota, and That means it will be used for all kinds of workload types. And after we have a minimal version, we can revisit the feature. Let's see if we need to introduce another field to declare the resource scope.
Yeah, I think that sounds like a good idea.
Okay. So okay. Uh, I also noticed that you mentioned that you did a test right here.
Yes. Yeah, so we currently maintain these changes on an internal fork. And so we
Mm,
have this running already on dev. The end-to-end request latency, all I did was essentially apply a bunch of resources recurrently and measure how long it took for us to get a response back once the application was applied. Um, so it was just a very simple test. One time the webhook was disabled, and so
mm,
we noticed it was about 370 milliseconds for the end-to-end request latency. When we turned the webhook on, that increased to about 390 milliseconds. But to be fair, like this wasn't really a large-scale test. It was just applying and deleting a single resource. So um, if we want to do more comprehensive performing tests before we decide to enable such a validation webhook, we can do that.
okay. Uh, I'm. Are you able to show how show the configuration of the admission webhook as well as the the code?
Yes. So the code itself is actually published as part of a PR. It's a bit outdated though because I haven't updated it um on Karmada, like the pull request itself in a while, but I can share that. Just let me find it quickly.
So do you want to share your screen?
Yes.
Okay, I'm stop sharing.
Can you see my screen?
Yeah,
Okay. So yeah,
first, okay.
this is a pretty old PR, so some of this is outdated, but um, the webhook configuration here, we specifically changed it so that it only affects our Flink deployments.
Yeah, yeah. That's the thing that I want to figure out. That yeah, in this um in this demo, the webhook just cares about the Flink deployment, right?
Correct.
Um, the first thing I'm thinking is if we need to introduce the webhook admission to Karmada project, the first thing we need to figure out what kind of workloads we need to cares about.
Hmm.
So it cannot be just uh, a limited list here.
Yeah.
Probably it need to watch its all kinds of resource types because we actually we don't know uh, what we don't know the workload type the user probably use. So that's a big difference between your demo. Um, so if the webhook need to watch all kind of a resource, so that brings another thing is the webhook will need to figure out which can figure out the resource if a resource type is a workload type. For example, maybe maybe when creating a config map, the webhook will be invoked. Um, the webhook needs to figure out if this is the resource type it need to cares about. If not, it's just return the response with OK. And if he if it needs to check quota, if it figure out this is a workload, and then it needs to check the quota. So uh, there, I think there is quite a lot of work to do for the webhook.
Yeah, that makes sense. I'm curious with the Kubernetes implementation,
Mm.
do they have a way of also filtering out which resources are picked up by the resource quota? Because otherwise, I would assume that that validation webhook would also be pretty chatty. Or perhaps I can go take a look at how it's implemented. I'm not sure. But
Yeah, that's a good question. I haven't looked at the how Kubernetes checks the quota. Oh, I remember Kubernetes just cares about the pods. So uh, the Kubernetes doesn't care uh, you deployed is a deployment replica set or other kind of a deployment or other kind of a workload. It doesn't care. It just perform the resource quota check when a pod is creating. So
I see.
Kubernetes just focus on pods.
So perhaps we could also consider just going with the admission controller idea as well. Um, and then just enforcing those quota limits when we're actually scheduling the resource. But
Mhm.
mm, there's some drawbacks to that as well. Mm.
Yeah, I think even though there's a lot of work to do in webhook, but I don't see any blocker here because we clear know what to do.
Yeah. Okay. So I can do some research on how we could maybe at least try to filter out resources that don't require any sort of resource check. Um,
Mhm.
I wouldn't want us because currently the way that we implemented the validation webhook is that if we, well, this already filters for Flink deployments, but once they're updated or created, we actually call the custom interpreter get replicas method, and then we fetch the required resources from what's returned. But I wouldn't want to do that for every single resource if we remove this being limited to just Flink deployments, because that's a lot of API calls, which I don't think is necessary. So yeah, I think we would maybe just have to implement some sort of filter within the webhook, or be smart about which API groups and API versions we're accepting, like
Yeah.
filtering for in the configuration.
Yeah. I think that's the thing the user need to care about when they configure the webhook configurations. If he, for example, uh, he wants a better performance, maybe they just need to configure the webhook configuration with limited resource type they care about.
Yeah, or we could even have the webhook be turned off by default, and if tenants want to use it, they can enable it for their use case. Mm,
Yeah, I think for your case, you can take the configuration like this, just the Flink deployments.
yeah.
Hmm.
Okay.
Okay. Uh, Another thing I want uh, to talk about is uh, I want to I want to try to share my understanding of your use case and make sure that we are on the same page. So, in your use case, there are as the administrator of a Kubernetes cluster, you probably assign quota to the the users, right? And and in the normal case, each user will use uh, each each user. Let me try share my screen to here. So let's take this example. Um, Here you assign a total quota to a user. Let's say you assigned 40 CPUs to that user, and probably the user deployed two Flink deployments on each memory cluster.
Hmm.
Each Flink deployment consumes 20 CPUs, and in this case, when one in one, let's say this Flink deployment need to fail over to memory 2 cluster. Um, the current situation is that there's no more resource quota for the user, so the application failover cannot be performed. Right? Is this
Uh,
the
that's correct. Just because the resource quota itself is statically assigned, so it
okay?
gets subdivided between the member clusters. So whenever we create a namespace for our users, we assign them a set number of CPUs and memory that they're limited to using overall. Um, so we want to, I guess, limit their usage to those limits that we've set. However, because you're statically assigning these quotas amongst the clusters, there isn't enough quota on a single cluster to allow failover to occur. So like, let's
Mm-hmm.
assume that we're setting a federated resource quota with 40 total CPU and 50 total gigs of memory, and we've subdivided those resource quotas amongst two clusters. Well, if one cluster fails for some reason and we want to trigger a failover, the other cluster won't actually accept those resources because the resource quota is only set to be 20 CPU and 25 gigs of memory, which actually I'm noticing this diagram I need to update because that's slightly incorrect.
Do you mean this? The 40
Correct.
needs to 20, 25, right?
Yeah, exactly. Because both of the member clusters should have essentially half of what the federated resource quota has defined.
Mm-hmm.
Um, and so when failover occurs, the second member cluster won't have enough like quota to
Okay.
allow those resources to fail over. So that's why
Okay.
we want to have the same quota be on each cluster, because the way that we capacity plan for our users is that um, if they're deploying a single application, then we actually provision them twice the amount of quota that they
Mm-hmm.
themselves budgeted for, because they're under the impression that when they schedule jobs onto our platform, if something ever happens to their cluster, they have a fallback cluster with the exact same quota as the cluster that they're currently using. So if it ever goes down, Karmada will reschedule those resources uh, to a different cluster, and that cluster will have sufficient capacity.
Mm. Okay, that good. I understand. So,
Can I have a question? So in a healthy status, let's say without failover, does that mean tenants can deploy twice of their workloads? Twice
mm,
of their budgeted quota?
With the existing static assignment, or
I mean, with a healthy, without failover, let's say those clusters, uh, those clusters are healthy. Does that mean tenants can deploy twice of their workloads?
oh, so yeah, if we don't use any sort of federated resource quota and we set quotas on the member clusters, then yeah, the Karmada control plane could continue scheduling applications and users could technically use more than they've been allotted for um, a single cluster.
Okay, that's the current status, right?
Correct, yeah. So the way that that's enforced currently is via static assignment, but there's a limitation there because these are statically signed resource quotas. If a failover ever happens, then the secondary cluster won't have enough space to pick up the work that's getting failed over.
Okay.
by the way, do you think it would make more clear if we um, add add two Flink deployments on this picture? One is in the member one cluster, and then the other one is on the member two cluster. Each Flink deployment uses 20 CPUs, 25 memories.
Mm-hmm. Yeah, I can do that.
Mm-hmm. Okay, sounds good. I will explore more about the implementation details, and will leave further comments on the proposal.
Okay, sounds good.
Okay, since we don't have any other agendas, so I guess next time I see you will be at London.
Yeah, see you in 2 weeks.
So Hello, Lin Yao.
Hey.
Hey.
So we'll also be here, but we'll be at the KubeCon, but we are onboarding onto our managed Karmada. So for our use case, it's pretty simple. So so we can chat. Yep.
Okay.
Cool.
Sound good. Okay. Let me stop the recording.